Okay, so we're going to call this session 8.2 homework help. Okay, we'll call that. And let's do 39 together. So in 39, we have a shark. The fork length of a shark is the distance from the tip of the shark's snout to the fork of its tail, as shown. Table lists equations giving the fork length, F, as a function of the total length for the three species of sharks, where both F and T are measured in centimeters. Okay, all right. So T is the total length? No. Fork length is F. T is the total length. Okay, got it. A, to the nearest centimeter, approximate the fork length of each given species of a shark that has a total length of 250 centimeters. So in A, they're giving us the total length, right? They're telling us that the total length is 250 centimeters. Okay? And we define the fork length for each of them. So for the big eye thresher, we have a formula that goes that F, the fork length, is equal to 0.560 T plus 17.7. Okay, so how would I find this? What would I have to do? How would I find the fork length? Wouldn't I just put this guy into here because T is equal to 250, right? So it's going to be 0.560 times 250 plus 17.7. Okay. And you would calculate that out. I'm not going to do that part, but you understand what's going on here, right? Okay, so that was the big eye thresher. For the scalloped hammerhead, the equation changes, and the equation is now 0.776 T minus 0.313. Right? Okay, so on this time we would do the same thing. You put the 250 in here, it would be 0.6776 times 250 minus 0.313. Okay. And then for the white shark, again, we have a different one. The white shark would be 0.944. And then you would put the 250 in there. And then you would subtract 5.74. Okay, so that was easy enough. All you're doing is putting wherever T is, you're putting 250 centimeters in there, right? And then you're just calculating it. B, for each species of shark, what percent of the total length does the fork length represent if the shark is 250 centimeters? Okay, so you would have to find the percent, right? So let's do this one. Since I've already got this up. This is the white shark. So if we did this, the white shark, we get 0.944, 250. So I get 0, 0, 2, 2, 47, 8, 8, 8, 1, 0, 0, 0. 5, 6, 3, 2. And I have 1, 2, 3, 1, 2, 3. So this is going to be equal to that. So this is going to be equal to 236 minus 5.74. So let's subtract that out. 6, 2, 0, 230. So this becomes 230.26. So this is the total length. This is the fork length. Is that what's called the fork length? The fork length. So the fork length is this. Now I want to know what percent that is of the total length, right? So the total length was 250 over 230.26 times 100, right? Because then I want the percentage, right? The percentage, you have to multiply by 100. So this is basically 203.26 over 250. And I would put it in my calculator just to know what percentage is. Okay, all right. So you're gonna have to do that for all of them. And then C, which species of shark do you think has the longest tail relative to its body size? So you would find which one has the largest percentage, right? And that's what they're looking for. Okay, so that's how you do 39. Let's do 40. In number 40, we have volcanoes. Again, we have volcanoes. The Hawaiian Emperor chain of volcanoes is shown at the left. The age A in millions of years of a volcano in the chain can be approximated by A is equal to 0.0129 D minus 2.25. So the age, 0.0129 D minus, 2.25, where D is the volcano's distance in kilometers from Kilauea, measured along the chain. A, Suiko is 479 kilometers from Kilauea, measured along the chain, approximately the age of it. So what is that? So what is the 4794? Isn't it this guy right here? It's the distance, right? So this would be 4794. You would just input that, then you would do the math. Okay? That's how you do A. B, Midway is about 27.7 million years old. So in this one, they're telling you that they're not giving you this, they're giving you this and saying this is 27.7. This is 27.7. So you're 27.7, then you have to figure out what D is. So how would you do that? So this would be 27.7. And how would you figure out for D? Anybody? I want to isolate D. So I need to get rid of this guy first, right? How would I get rid of this guy? Pastor, how would I get rid of this guy? And I add 2.25 on both sides, right? Yeah. 2.25. If I add this guy goes away. On this side, I end up with 0.0129 D. On this guy, I end up with 29.95. So how many I solve for D? Logan?
I'm going to divide them.
I'm going to divide both sides by 0.0129, right? I divide both sides by 0.0129. This guy now goes away. All I have left is D, and that's what I was trying to accomplish, right? So D is going to be equal to 29.95 divided by 0.0129. Okay? And that's how you would solve B. Flip the page. Is there a C? No, there's no C. do 41. Platypus. Anybody know what anybody seen a platypus before? In the zoo, right? Why are platypuses so important? Aren't they like the cross between living in the land and living in the river or something like that or whatever? I don't know. There's some sort of link.
Mammals, but they lay eggs. So
Oh, is there what?
they're mammals.
But they lay eggs. Okay, so there you go. Thank you. All right, so they are mammals, but they lay eggs. Okay, mammals usually do not lay eggs, right? Cool. Platypus is an animal with a broad, flat tail, webbed feet, and a snout like a duck's bill. Although a platypus spends much of its time in the water, it can also walk on land. Diagram below shows one complete stride of a walking platypus. The stride frequency, F, is the number of strides per second the platypus takes. It can be approximated using that equation where S is the speed of the platypus in meters per second. Okay, so you're gonna have F is equal to 2.13 S plus 1.19. Okay, A, solve the given equation for S to obtain the equation that gives speed as a function of the stride frequency. So we're going to solve for S. It's kind of like the same thing we just did. Okay, we want to solve for S, just like we did last time. We need to get rid of this guy first. And the way to do that is to subtract 1.19 from both sides. 9. So this guy now goes away. I end up with F minus 1.19 here. I get 2.13 S. So I have to divide everything by 2.13. So on this side, this goes away. So I'm going to have S is equal to 1 over 2.13 F minus 1.19 divided by 2.13, and you'd have to do the calculation. You have to calculate that, and you can actually calculate this too, to take it out from a fraction, right? So that's how you would do that. B, use the equation from part A to approximate the speed of a platypus that takes 3 strides per second. So the F, the frequency, is 3 strides per second. So we'll just go ahead and input that right there. 3 minus 1.19 over 2.13, which actually is the same as if I combine them. I go 3 minus 1.19, 1.81 over 2.13, whatever that is. Can't help me your answer. Okay. And we're good. You want me to do 42 also? You guys think you can do 42?
Answer 41?
Huh?
What was the answer to 41? You never told us that you're wrong.
You have to do the calculations. I'm not going to do all the calculations. I mean, that's up to you to figure out. Okay. All right. So we'll call it good. You guys can go ahead and start working. I'm going to go ahead and I'll go ahead and put this on the